Welcome to at Inspired Teacher YouTube account. Now if you are new here, please take a second or two, then subscribe, like and share the video. Now today we are going to look at the solution of the differential wave equation. If you haven't known how to derive the differential wave equation yet, then I have done a video on the same, and I'm going to provide the link so that you can have an access of it. Now we are going to give the solution of the differential wave equation to an extent of getting the maximum velocity of simple harmonic motion. And we are going to start from the acceleration. This is the differential wave equation. So acceleration A is given by differentiating displacement 2 times. So it's given by x differentiating the displacement 2 times, and it's written as d squared over x, then d all over dt. Now this dx squared divided by dt squared is written as, it can also be written as d all over dt in bracket dx all over dt in brackets. Now after you've written in this format, then you shall have to multiply by dx. You have to multiply by dx on both the numerator and the denominator. Now when you multiply dx by this, you will get dx divided by dt. Then when you multiply this dx by the denominator of d divided by dt, then you shall have d all over dx in brackets. Then you write dx over dt as a whole. You write this one as now a whole here, dx divided by dt. Now after you've written like that, then you realize that dx all over dt is the velocity, and dx all over dt is also velocity, v. Now after you've written this way, you can now write as v, then d all over dx, then this v. Now this becomes the final format of the acceleration. Now after you've written like this can also be written as, it is also true to say that v dx multiplied by v is equal to d all over dx v squared divided by 2. So this one is equal to this one, or this one can also be written as this. So you carry this one into this equation, this differential wave equation, and write it this way: d divided by dx in brackets v squared divided by 2 in brackets. Then you come and carry the whole of this one, the plus omega squared x is equal to 0. Now after writing like this, you realize that omega squared x can also be written as d all over dx in brackets omega squared x squared divided by 2. So omega squared times x can also be written as this. Now you carry the whole of this equation into replacing this one. Now the new equation formed shall have d all over dx in brackets v squared all over 2 in brackets plus this one d all over dx in brackets omega squared x squared all over 2 now is equal to 0. After writing like that, then you shall have to collect the like terms together. So this one, d all over dx, is the same as d all over dx. So we shall write like d all over dx in brackets v squared all over 2, then plus omega squared x squared divided by 2 in bracket is equal to 0. Now after writing like that, because they share the same denominator, which is 2, then you shall have to write d all over dx in brackets v squared plus omega squared x squared all divided by 2 is equal to 0. Now, you multiply by 2 so that we can eliminate 2 on the denominator. We shall have times 2, then times 2. So these 2 shall cancel with this, then 2 times 0, we shall have 0. So we shall write the final one as d all over dx in brackets v squared plus omega squared x squared. Now this becomes our equation. Now, after getting this, shall have to integrate. So this is equal to 0. Shall have to integrate with respect to x, integrate that, then integrate with respect to x. So after integrating, we shall have the final answer as v squared plus omega squared x squared is equal to, after integrating 0, we shall get a constant c. Now, after reaching here, we shall have an assumption that at maximum displacement, then v is equal to 0. At maximum displacement, v is equals to 0. So we shall have to replace 0 here plus omega squared x squared is equals to c. Now, after getting that, shall have x, which is displacement, is always equal to plus or minus a. A for this case stands for amplitude. Now you need to replace here. You need to take this a and replace here. Now we shall have omega squared x squared is equal to c. But now, after replacing x with a, so we shall have here a squared. Now we realize that c, which is our constant, is equal to omega squared a squared. Now we shall have to carry the whole of this and replace it here. So we shall have this equation v squared plus omega squared x squared is equal to, now this one, the omega squared times a squared. This is omega squared a squared. Now, when you want to make v the subject of the formula, so v squared shall be equal to omega squared a squared. Then this one, when crosses on the other side, shall become negative. So it shall be negative omega squared x squared. After getting that, you need to collect the like terms together. You need to know that we have omega here and you have omega here. So these are like terms. So v squared becomes equal to omega squared in brackets a squared minus x squared. After closing the bracket, we find the square root so that we can get v alone. So we shall have to do the square root of v squared, then the square root of this one. So the final one, we shall have v is equal to the square root of omega squared shall have omega, then the square root of this shall be written as square root of a squared minus x squared. Now, after reaching here, we have an assumption that at maximum, we shall have an assumption that at maximum velocity, then v is equal to 0. So when at maximum velocity, then x is equal to 0, shall be written as v is equal to omega, so the square root of a squared. Now this was 0, so we shall have to eliminate it. Now we do to find the square root of a squared, shall be written as v is equals to omega a squared. Not a squared. Omega, the square root of a squared is equals to a. Now we shall have v is equals to omega times a. For this case, a is equals to amplitude, and this omega is equals to angular frequency, and this v is equals to maximum velocity. So after reaching here, so you shall have given the final answer, which is the maximum velocity